Welcome. Good afternoon. I hope you had a good break. Now it's the next 15 minutes about additive manufacturing and sustainability. About 3 weeks ago, I asked in LinkedIn the community about their opinion. Is sustainability accelerating additive manufacturing? Yes, no, or it depends. So the result was 83% answered the question with yes or it depends. So let's make a quick check here in the audience. Who would answer with yes? Okay, who would say no, it's not accelerating? Very few. Who would say it depends? Okay, a similar picture, a little more yes and it depends here, because probably we are here more the additive leading community in Berlin, and it's great to have so many of you here. Please don't develop a new carbon calculation tool. It's not anymore about developing the tools. The tools are at hand. EOS is having a tool, AM Power is having a tool, Siemens is having a tool to calculate the CO2 footprint. Yes, you need to know it for each and every product, but don't develop another tool. Let's look on multiple action fields and differentiate in these action fields what is beneficial for sustainability of additive manufacturing and where additive is a kind of tool help you that with additive you can make production and industries more sustainable. Here you see 7 action fields. Due to time, I probably will not be able to tell you about all of these 7, but let's go into that and start with the power of design. If you look, the design phase is the most important phase for sustainability. And first in history, now it's able to really produce what you can design by additive manufacturing. 80% of all product-related environmental impacts are defined and determined during the product design phase. We have 2 major levers with additive manufacturing in this area, and yes, it's saving materials between 30, 40, up to 60, 70% per product by using topology optimization tools. And it's as well helping products to be higher in performance by using intelligent simulation tools and validation with the tools for the products in use. Let's start with a pretty simple example. And if you calculate in the world, we have about 3 billion gripper installed in production facilities. And each of these gripper has a gripper to put things from A to B. And here in a big body shop of an automotive factory, and you can see these kind of factories in many different automotive or battery companies, have normally between 100 and 1,000 large robotic installations. And all of these normally use metallic pads. Here, in this case, it was a 60-kilogram metallic steel aluminum gripper out of several hundred parts mounted together. And a clever engineer from Siemens took this old gripper, applied topology optimization tools as well, FEM validation to simulate the performance, and he came up with a reduction of 82% lower carbon footprint. And at the same time, he was able to reduce the number of parts, make the part faster in delivery, and as well have a cost reduction of 73%. So this example is pretty easy to install, because wherever you have a factory, you see gripper, just immediately consider this should be done by additive manufacturing. Or take a second example, which is not as simple, because this is a product in use. You see a small movie behind me. This is a big battery. And in a battery, cooling is a very sophisticated technology because you need to cool the battery to have the same performance all the time, as well as you need the battery to not alter after several thousand hours. And here, this part you've just seen is a flow splitter, which is making sure that the battery cooling water is going everywhere, very homogeneous. And now you see this is packed, this is nested, this is simulated. This is designed by software, intelligent software tools, and this cannot be produced anymore by injection molding. And this kind of part is able, pretty tiny part, is able to improve the reduction, or is reducing the pressure drop by 47%, which is an increase in flow. Now consider that you need less electricity while driving, you have a better performance just because of a tiny part which makes the car probably in operation more sustainable. Or take a third example, and Christoph Kiener, one of our famous principal experts, he is here in Berlin and he's at the show, and he considered a simple part like a screw for a venting equipment for the process industry and applied as well onto this simple screw, high sophisticated FEM, design space exploration, and he could realize a fully new function of a screw, which at the end is built with certain amount inside of the screw out of porous materials. So what is happening? The performance is increasing compared to the original parts mounted and assembled, different parts to make the same function. CO2 footprint is reduced by 38%. So this shows you in the early design phase, we have the use case, we just need to apply and scale these use cases. And now go into the industrial production, which is our second action field we need to look at. And 70 million tons of CO2 emissions can be saved each year if we just reduce 1% in the carbon footprint in the industrial production space. And let's go into that, what you can do. Yes, you can save energy. Try to use least energy as possible and try to use fewer materials, byproducts, media, gases, whatever. And let's look back into our gripper example. Now the gripper was designed, was built. It's already a cool case with a return of invest. Now let's mount this gripper onto the robotic system. With this reduction of weight, you need less space, you need less energy for the robot, and by that, in a one-year operation, you need significant several tons less CO2 per robotic system in a body shop factory, just by a simple part like a gripper, which is reduced in weight, and as well, the footprint and the whole space in the factory is reduced. Or take another example where we've had the gripper. Now, if there's a demand of 200,000 of these gripper, we already showed in the design, yes, we need to pack it in the nesting as dense as possible to make it most efficient and productive. But here, just recently, we've worked on an automation concept in the partnership with EOS for the Hannover Fair. And in the past, you've had this big P500 system from EOS. You needed 15 machines to produce in a one-shift operation these 210,000 parts. With a clever automation with Dimension, Grenzebach, EOS, and automated with the help from our colleagues, it is now possible to use only 9 machines to produce the same quantity. So, and it's always the same rationale, it's more for less to make it more sustainable. Let's move on into the life cycle where you say, okay, this is a big issue because only 13% of the global waste is recycled. And this is something we can help all by ourselves. We need to use products much longer in the life cycle This is the easiest lever towards sustainability. Use your products longer if they are breaking, and we have seen great examples from Siemens Mobility or other colleagues. We need to repair instead of producing new parts. And this is a cool example. Once more, how is it done? Based on a robotics machine, Chiron has achieved a process for DED with multi-axis driven for a company here, which is Hammerwerk Friedingen, and you will find this solution for a cutting tool. Normally you have 16,000 cycles of this cutting tool, and this is now repaired after these 16,000 cycles, and you can now do 40,000 cycles with the same cutting tool. And you can apply the same principle to molds or other parts. Especially the DED technology is a favorable technology in additive to repair parts as well, combined with intelligent machining. Now let's look into the supply chain. We all are sending parts back and forth through the world, and in this area, this has a huge impact. First of all, it needs transparency. You need to know in which kind of logistics process, which kind of carbon footprint is coming up, is arising. And secondly, you need to find ways how you optimize your logistics and supply chain along the full process. We at Siemens, we have 190 printers installed all over our facilities. We have in the meantime installed a distributed manufacturing network to solve this order management problem with 450 users attached to this digital platform. We will hear a little more in detail tomorrow from Sonja Wolfram about how this works in detail per plant and per factory. What are we doing with it? It's about getting utilization up. Not every factory needs an own printer which is underutilized. We need to fill the printers with load that we have the most sustainable production, and we try to find the nearest location to the demand to produce with this tool, which is, by the way, a commercial tool. This is the AIM network, where we have a seamless integration, integrated with ERP systems and all over the plant. But even beyond that, there are more platforms out. I don't know if Markus Seibold is here in the room. I saw him around at the conference. We've made an integration with Makerverse. By that, we need to integrate further platforms, a platform-to-platform connection, to make the seamless journey for the order management happen, and by that, giving access everybody, most local, by digital manufacturing platforms to keep logistics, environmental footprint as low as possible. Let's look on the last two action areas very smoothly, and one is electrification. You would say, electrification? What is he talking at the Additive conference? Yes, everybody who's running machines of you, probably there are easy things. Try to convey and make your factory being electrified with renewable energy, and as well look how you can save this energy in your whole production process. However, I brought an opposite example here from my former colleagues of Siemens Energy. And as well, additive manufacturing is playing a role in helping the energy transformation in the world. And the Siemens Energy guys made it possible. You see 3 examples, a guide vane, as well a burner for a gas turbine and an heat exchanger. These kind of parts can only be produced by additive. They are specifically designed with knowledge on materials, machine, as well as the application. And by that, you can start to burn now hydrogen only because of additive. So once more, a different view on the electrification, how additive manufacturing is once more an enabler tool towards more sustainability. Last week, Stefanie Brickwede and myself, we've had the first construction workshop here in Berlin. And once more, as well, buildings Buildings is an issue from the construction of the building as well running of the building in terms of carbon footprint as well in terms of energy saving. Some of your colleagues are already working on heat exchanger or in different applications, but here in this example, we saw a great example from 14 Trees, which is a South Africa-based company, showing that by building additive manufactured houses, you can reduce the carbon footprint up to 70% with a 20% cost reduction. So summing it up, there are a lot of action fields. The use cases are at hand. We need to make it happen, to scale, to accelerate it. And I think everybody of you in your industry, in your area, have a lot of work to do. And by that, I want to conclude, for me, it's a yes. It depends only on us as a leading additive manufacturing community. By that, thank you for this time and for listening.
Thank you so much, Karsten, for this insightful presentation. Thanks for sharing the real-life examples on sustainability and AM.